morning, all students. Myself Shubham here. So currently, I'm a program manager at MIT University Online. So currently, I'm acting as a vertical head to manage the blockchain and cyber security online programs. So today we have webinar on blockchain. So this specific like blockchain in business with Hyperledger Fabric. Today we have instructor Mr. Nakul Shah, who has conducted a lot of training sessions and conferences through across the globe. Okay, so currently he's a director at Slate Development, and which is blockchain organization to create enterprise solutions. And Mr. Nakul Shah also has written a book on blockchain for business with Hyperledger Fabric. So he's the author of that book. So now I request Mr. Nakusha to start with this webinar. So Mr. Nakusha, you can continue.
Sure. Thanks, Shubham, and a very good morning to all. Welcome to this webinar on Hyperledger by Amity. And Shubham has already introduced me, so thanks, Shubham, for doing that. Now, before we get started with today's session, let me just go over the agenda for today and a few house rules that will help us better interact with each other. First and foremost, we are going to start by understanding what Hyperledger exactly is and why exactly does it hold a certain amount of significance in today's IT industry. Why do we need Hyperledger? Why industry is moving towards adopting this technology? Then I'm going to briefly demonstrate through a simplistic example as to how Hyperledger works and what is the disparity between Hyperledger and some of the other blockchain platforms that you all already might be aware of, like Ethereum blockchain or Bitcoin blockchain, etc. Then we'll talk about the projects under Hyperledger umbrella, and we'll discuss one of them in detail, which is Hyperledger Fabric. Fabric is one of the most widely used platforms within the Hyperledger umbrella, and it has a great following. It has a number of different use cases and POCs built on top of it. So we are going to talk briefly about Fabric, and finally, to conclude today's session, we'll go through a small demo on Hyperledger. First, I'll use Composer, which is a Bluemix platform, web-based platform, and then we'll use a Dockerized system to explain the same concept. So that is what we are going to go through today. And during the session, I believe all of y'all are going to be on mute. But at any point, if y'all have a question, if y'all have a query, or if a certain concept that I've explained is not clear to y'all, just post your question on the in the questions tab on the GoToWebinar control panel that y'all are using at present. And as and when the questions keep coming in, I'll pick them up and I'll answer them. If I feel that a particular question is not directly relevant to what we are looking at or is probably going to be covered later on in today's session, then I'll put those kind of questions in the parking lot and I'll pick them up at the appropriate time. And either at the appropriate time or towards the end of the session, whatever is most ideal and most suited for the question. But please feel free to ask me any questions, any doubts, any queries. So, without further ado, let's get started with today's session on Hyperledger. Are we good to go, Shubham, or should we wait for anyone else who's joining?
No, we are good to go.
Good to go. All right, sounds good. So before we talk more about Hyperledger, I want to tell you what Hyperledger is not. So before I explain what Hyperledger is, how it is used, it's very important to understand or to clear out some of the misconceptions that you guys might have, or some misconceptions that might have been reached due to misinformation or due to wrong communication. So I want to first clear out that air. Now, that's why before I tell you what Hyperledger is, let me tell you what Hyperledger isn't. Because it's really easy to get confused in today's world with so many blockchain platforms around you. So, firstly, Hyperledger is not a cryptocurrency. Uh, Normally, people seem to be more interested in today's world in the concept of cryptocurrency, especially because of the increase in its value. If you take a look at Bitcoin, it started off back in 2009, 2010. Its worth was hardly a couple of dollars. It flew to $1,000, and eventually, towards the end of 2017, it touched $20,000. So, cryptocurrency is an aspect people are more interested in as compared to blockchain. From a financial perspective, that makes sense, but from a technology perspective, which is going to be our topic today, the underlying platform is of more importance, and that is what we term as blockchain. And Hyperledger itself is, it's not a cryptocurrency, it's nowhere even related to cryptocurrency. Above that, Hyperledger itself is not even a blockchain. As we move forward, I'll demystify this concept further, but Hyperledger is basically an umbrella, and within that umbrella comes different blockchain platforms. So you have Fabric, you have Sawtooth Lake, you have Iroha. So there are various different platforms under the Hyperledger umbrella, but Hyperledger itself is not a blockchain. And lastly, Hyperledger is not even a company. It's not a corporation. So now that I've told you what Hyperledger is not, let me tell you what Hyperledger exactly is. So to begin with Hyperledger, Hyperledger is a project under the Linux Foundation. Now, Linux Foundation has been known for creating a number of open source projects. So they have projects like Drone Code, Acumus, Aljoin, Node.js, etc. And all these projects have been created by the Linux Foundation. All of them are open source projects. The vision behind creating these projects was to promote them in the industry, get different organizations and stakeholders to be a part of these technologies, to utilize these technologies. And similar is the case with Hyperledger as well. So Hyperledger is also an open source project that comes under Linux Foundation, where people from all over the planet can come and help Hyperledger get developed as a software and as a platform. And within Hyperledger, you have these different platforms. Each of those platforms initially were contributed to by different organizations. Like Fabric was initially contributed to by IBM, Sawtooth Lake by Intel, and so on and so forth. And after the initial contribution, and after they came under the Linux Foundation, who made it open source, different industries, different developers have contributed to their code. They've helped improve the platform further, add more functionalities, align it with the industry requirement. So that is what Hyperledger is. It's basically an umbrella project under which different platforms come. Now, according to the executive director of Hyperledger, Brian Bellendorf, Hyperledger is basically an open source community of communities to benefit an ecosystem of Hyperledger based solution providers and users focused on blockchain related use cases that will work across a variety of industrial sectors. So, what that basically means is that uh, within Hyperledger, so one common concept about blockchain that if you all haven't understood so far, it's really important to get a grasp on that. Blockchain has benefits, it has a lot of advantages, but only if multiple organizations are using it together. So you cannot just implement blockchain in your own organization or own company and say that I'm getting the benefits of blockchain. Blockchain is not going to bring you any benefits if you all are working on it in your own silos. So consider it like an email ID. Now, just because I have an email ID, it doesn't bring any benefit to me unless and until my colleagues, my friends, my family, my business partners, they are all using an email ID. So only if they have an email ID can we communicate using it. But if none of them are using an email ID, then I having an email ID is of no advantage. So same is the case with blockchain, and more importantly with enterprise platforms like Hyperledger, wherein the advantage really comes in only when multiple organizations are using it together, they're using it collaboratively. So that's why the vision of creating something like Hyperledger was to bring these different communities, whether these communities can consist of individual developers, they can consist of companies, they can consist of startups, they can also consist of governments and various individual developers. So it's the idea is to bring this entire community together and work collaboratively in testing out the platform, building the platform, and then developing and deploying solutions on top of it. So that is what the entire vision of Hyperledger is. That is where Hyperledger basically comes from. So, what exactly does all this mean? Now, in simpler terms, Hyperledger can be thought of as a software that enables developers all across the globe to develop blockchain-based solutions for their particular businesses. Now, at this point, some of you who are slightly versed with blockchain technology might be thinking that, hey, we have platforms like Ethereum, and why can't they do what Hyperledger does? Well, the ethos of Hyperledger is that it believes every business or industry is unique in its own ways, and an application standing for that service must be personalized, unlike Ethereum blockchain or Bitcoin blockchain or some of these other open source protocols, which are very generalized for everything that runs on its network. And as we move forward, you'll see what I mean over here, what basically this entails. Now, let me give you a brief history about Hyperledger before diving deeper into its mechanics. So, first of all, Hyperledger began as a small project by a limited number of developers who came from various sectors like finance, supply chain, data management, insurance, and some of the other sectors as well. And all these people, they had one common goal in mind, and that is to make the blockchain as a technology more accessible to the world. So, with these things in mind, developers started testing the interactions between applications and the secure blockchain network. Now, the issue prior to Hyperledger was that these solutions like Ethereum blockchain and Bitcoin blockchain, they were already there. And initially, when Bitcoin blockchain was developed, the goal was only to make financial transactions. So with Bitcoin blockchain, you could only send and receive cryptocurrencies, and that's it. Bitcoin blockchain couldn't be used for anything else. And one of the technical reasons behind that was Bitcoin's Turing incompleteness. So Turing incompleteness is a design a feature in any programming language. And what that basically means is that, let me just pull up a Word document so I can explain this concept better, this concept of Turing incompleteness. Just 1 second. Yeah. I hope everyone can see this Word document. In case you all can't, just let me know. So basically, we are talking about Turing incompleteness now. Now, in order to explain what Turing incompleteness means, I'll need to first explain what Turing completeness exactly means. So now, let's say there is a certain software that I'm writing. So, just one second. A certain software or a certain smart contract that I'm trying to write now. Now, what the purpose of the smart contract is to check whether a particular car belongs to the Hyundai company or no. So Hyundai is the company that I'm trying to test, and I have different cars which I want to test. So let's say I have 4 cars. I have Civic, then I have Swift, then I have a Creta, and I have let's say uh, an XF. So these are the 4 cars that I have. Now, normally when I write a program to test if these cars belong to the Hyundai company, what I'll do is I'll use a for loop. So for those who don't come from a coding background. Basically, a for loop is it's a repetitive motion in a code, wherein the code will keep running in that section. So in our example, this for loop means that the code will keep checking for the Hyundai company for as long as it doesn't find the correct car, and as soon as it does, it will break out of the for loop and it will give you the output. So in this case, I'll be giving the code these four inputs: Civic, Swift, Creta, XF, and the way the code will run is that first it will check for Civic. If Civic belongs to Hyundai, well and good. If not, then it will again go up, check for Swift. If not, it will go up, check for Creta. And because Creta belongs to Hyundai, it will give me an output which says Creta. So this is how the contract, the software code will work when it is Turing complete. But if the same thing is Turing incomplete, then writing this for loop is not possible. So you cannot write this looping condition. And secondly, you cannot get a specific output. The only kind of output that you can get is either true or false. So in that case, what would happen is that if I want to run this kind of a code, basically I'll have to run this code with each entity. So I'll run this code with Civic, and I'll check if Civic actually belongs to Hyundai. If not, then I'll have to go back, make alterations to the core code, change Civic to Swift, and then again deploy the code and execute it to check if Swift belongs to Hyundai. And I'll have to repeat that methodology for each and every input. So that is a very tedious activity. And in Turing incompleteness, that's the only way. So for that reason, Bitcoin blockchain, which is Turing incomplete, it couldn't support any kind of smart contracts or any kind of programs to get executed on top of it. And for that very reason, the industry decided that if they want to get the benefits of blockchain, if they want to actually leverage blockchain as a technology for enterprise solutions, for different use cases, and actually get advantage of blockchain, then they have to develop something which is Turing complete. And then began the entire industry of using blockchain for enterprise solutions. So at that point came Ethereum blockchain, which was Turing complete, Hyperledger, and various other similar projects. So they started coming to the market, and these innovations, these developments, they started almost half a decade after Bitcoin blockchain. Because initially, like when Bitcoin blockchain had just started, people didn't even know that the concept of blockchain exists. So for people, it was all about Bitcoin. It's only when Bitcoin started gaining some value. So initially, it was sold for hardly a few cents. In fact, back in 2010, some individual, he bought a pizza for 10,000 bitcoins. Now, and this is not long back ago. So this is hardly 8 or 10 years back. So you can imagine 10,000 bitcoins being spent for a pizza, and today each bitcoin is worth almost $10,000. So that's how far Bitcoin has come. But initially, when this increment in the value started of Bitcoin, from few cents to a few dollars, then hundreds of dollars, and finally thousands of dollars. That is when a lot of enterprises started looking under the covers, because if you look at these enterprises, most of the enterprises, especially within the financial system, their entire business is based on trust. Today I cannot trust an individual or a stranger with my money, and I don't even find it safe to keep my money at home. So what I do is I go to a bank, I deposit my money over there, and I hope that the bank will give me my money back when I request for it, or they will hand it over to whichever other party I tell them to. But in 2008 2009, when the entire global meltdown started, uh, and a lot of banking institutions started going out of business, plus different restrictions started being imposed on banks. So for instance, in a lot of European nations, banks started putting in they started putting this restriction that an individual cannot withdraw more than a certain amount of money in a day. So my money in my bank account, which I have earned, yet I do not have the privilege of withdrawing it. That kind of a concept, that kind of an idea was a little unsettling for people. And that is when they started, they started hoping for a system which could actually allow them to transact in money at their own convenience. So the entire prerogative of transacting with their money should be in the hands of the people. And coincidentally, that is when Bitcoin came to the market, which is one of the reasons why in the initial days its adoption was significant. Of course, when this adoption started growing, and with that the value of Bitcoin started growing, a lot of people started looking under the covers, because they wanted to understand what is this technology which is actually making the existence of banks or these institutions completely moot. Because people who used to rely on these banking institutions for the sole reason of trust were now being able to use this technology, and the technology was working flawlessly. It was working in a seamless manner, with people being able to transact with each other without any kind of frauds, without any kind of uh, issues with the technology. So that is when they started looking under the covers, and that's when the concept of blockchain actually emerged, and people realized that cryptocurrency is just one small application of blockchain, but blockchain as a technology is capable of doing much more. So that's when they started building these alternate platforms like Ethereum and Hyperledger, in order to utilize this concept of blockchain, but for various other use cases and applications. And one of the prime goals was to make it Turing complete. Each of these other blockchains that have been developed, especially for enterprise purposes, have been Turing complete blockchains. So they can build smart contracts on top of it, they can build applications on top of it, and use it for different purposes. So that is where the history or the entire birth of this concept of blockchain basically comes from. All right. Any questions so far, guys? Is everyone with me? Any questions? Any queries? Any questions, guys? So if everyone is with me, can I get a yes from everyone? So I know that you are following and all is good so far. Okay, I don't see any questions or any comments here. I hope everyone is following. Let me know if there are any questions or any queries. So in the meantime, let's move forward. Now, when we are talking about blockchain, so while rigorous testing was being done on the application side and the security of blockchain, developers involved, they started realizing that these public blockchains, like Ethereum, Zcash, and even Neo and NEM, these blockchains require each pair to execute each and every transaction and run the consensus at the same time. And this takes a huge blow when it comes to scalability, as the network takes a really exhaustive measure to ensure security. At the same time, even the confidentiality of the data is it's not kept intact. And above that, any transaction that has a measure of confidentiality and privacy attached to it cannot be executed on the blockchain due to its public nature, as every ledger on the network will get updated and confidentiality will be lost. So this was a prime concern for platforms like Ethereum and a few others. And in order to overcome these concerns and in order to make blockchain more usable for enterprise, they started building this Hyperledger, the Hyperledger umbrella project, and various platforms under it. So let's understand what the major concern in this case was. So let me again pull up my Word document. All right. Now I'm assuming that you all have some background in Ethereum, but still I'll start from a little basic of that aspect. So I'll be comparing Ethereum blockchain with Hyperledger in order to show the reason or the purpose behind creating something like Hyperledger. So in case of Ethereum blockchain, I'm sure you all must be aware of the concept of nodes. So there are different nodes on Ethereum blockchain, and each node is a part of the Ethereum network. So whenever you deploy a certain transaction or a certain smart contract, it's available with each and every node. And each and every node has a copy of that smart contract. Each node can interact with that smart contract or create transactions on that smart contract. So that is what Ethereum blockchain is all about. Now, let's say I have deployed a certain smart contract, SM1, and
Hello,
yeah,
Mr. Nakul. I think there
yeah,
are some questions. Okay.
sure, sure.
So just 1 minute. Just 1 minute. Okay. I think. Uh, yeah. So question is how Hyperledger is different from other blockchain framework.
Okay, so I'll put that question on hold for now because later on in this module, we have a slide where I'm going to differentiate between Hyperledger, Ethereum, and Bitcoin blockchain. So at that point, I'll be covering the exact difference based on certain criteria and certain characteristics.
Okay. Okay.
Any other
Yeah.
question?
So yeah. So is Hyperledger distributed ledger but not blockchain?
Sorry, come again.
Is Hyperledger distributed ledger but not blockchain? Is the
Yeah,
question.
so sure. So, see, firstly, Hyperledger is not either. As we saw in the initial slides, Hyperledger itself is not a platform. Within Hyperledger, there are different platforms like Fabric, Sawtooth Lake, Iroha, Indy, and several others. Now, these platforms are more regarded as a distributed ledger as opposed to blockchain. Now, you all might ask me that what is the difference between the two? So, the difference is not major. Usually, for an enterprise purpose where transactions are more important than creation of blocks for those transactions, or where in every individual transaction gets confirmed rather than a block of transactions. That is where the difference lies between distributed ledger and blockchain. So in a blockchain, it's all about confirming blocks of transactions and adding those blocks one after the other. Whereas in distributed ledger, usually the confirmation stays at a transaction level. So each and every transaction needs to get confirmed. Each and every transaction needs to get validated, and that is where distributed ledger works. So to answer the question, yes, now, all platforms under Hyperledger, they are more aligned as a distributed ledger, but every blockchain is basically a subset of the distributed ledger. Make sense?
Yeah. Okay. Just a minute. Okay. You can continue now.
All right, fine. Any other questions? Any other doubts? Okay, so let's move forward. So as I was explaining about Ethereum, now in Ethereum, what happens is that we have these different nodes, and anytime you deploy a certain smart contract or a certain transaction, or uh, you interact with that particular blockchain, each node has a copy of that transaction, each node has a copy of that smart contract. So we are taking one similar example. Let's say I have a certain contract SM1 and I deploy it on the Ethereum blockchain. So every node on the Ethereum blockchain now has a copy of that smart contract. Now, when every node has a copy of that smart contract, let's say if associated with that smart contract, now I initiate a transaction from node 1. So this transaction, which is initiated from node 1, will also get propagated throughout the entire blockchain, which means that every node in the blockchain will have a copy of this transaction TX1 as well. So now, even though this transaction is encrypted and the identities are secure, yet every node at least knows that a transaction did take place and the transaction was pertaining to the specific smart contract. So, even though the transaction is in the form of bytecodes, the other nodes can still reverse engineer the bytecode to predict what the smart contract could be, or to predict what the transaction could be. And the other nodes will, they might not know what the value has been which has been passed, but they will at least know that a certain value has been passed, or a certain transaction has been passed in this specific smart contract. Now let's say that this smart contract belongs to a banking system, and if you know about the banking system, so let's say me and my friend who have the same qualification, the same experience, the same background, we both go to a specific bank and a specific branch to get a loan from there. And we both want to start the same line of business. Now, when I present my proposal and my friend presents his proposal, it's possible that if I have a better relation with that bank, or if I have been banking with them for quite some years, or if I know the bank manager better, then it's possible that they might offer me a better interest rate or better loan terms as compared to my friend. Similar is the case with credit cards. So if I go to get a credit card, some people get the same credit card at a low fee. For some people, the fee is completely removed. For some people, the fee is higher. So all those kind of disparities exist in this enterprise world. And these enterprises, these banks, they do not want all this data to be completely public or all this data to be posted out there. So if you consider the Ethereum blockchain, and if you assume that the banks start using that for their enterprise applications, then it's going to be a disaster for them, because if I get a better loan term as compared to my friend, or a better interest rate as compared to my friend, and all that data is public, all that data is transparent, then my friend is going to go approach the bank saying that why has he gotten a better rate than me? So the banks prefer this kind of data to stay confidential, and there has to be some level of privacy when this kind of data is being considered. So if this specific data relates to me, then only I and my bank can have a look at that data and no one else. So for that very reason, public blockchains like Ethereum and all weren't ideal for banking applications. And for that specific reason, they started building alternate platforms like Hyperledger Fabric. So in Hyperledger Fabric, you can restrict the transactions. You can say that the transactions are viewed by only a few parties, or only these specific pre-approved parties can be a part of a certain business network. So this is where Hyperledger comes and wins the game. On a Hyperledger-based network, the parties were directly affiliated with the deal, are connected, and the ledgers that get updated about the special deal are only for those specific people. So in the example that I gave you, it would be me and the bank, or it would be my friend and the bank, who will be parties to that to the entries in the ledger pertaining to that specific transaction. So that was the entire reason why Hyperledger came to the market, why they had to develop something like Hyperledger and utilize it for enterprise purposes. So moving forward, sorry, you'll just have to bear with this because every time I switch from the PPT to the Word document in order to explain a certain concept, I have to restart the PPT. So just bear with me over here. Now,
Yeah, Mr. Nakul, there are two questions here for that the
yeah,
doc. So the question is, each and every transaction get replicated to every node. Is that not network intensive? How network is optimized in that case?
sure. So that's the other reason. Like when each and every transaction is getting propagated to each and every node, that involves a lot of resources and it sometimes clogs up the network. So if you take a look at Ethereum blockchain, for instance, I think about a year or a year and a half back, there was a game which was deployed on the Ethereum blockchain. The name of the game was CryptoKitties. Now, when CryptoKitties was launched, in the first week, a lot of users they started playing that game. They started downloading that game and interacting with that game, and because of this, the entire Ethereum blockchain got clogged. So a lot of transactions they stayed in pending for quite some time because the amount of resources required to propagate a transaction in every node, considering that there are thousands and thousands of nodes distributed all across the globe, the amount of energy required is huge. So it certainly is very network intensive. And this was the other reason for building platforms like Hyperledger, where firstly, the entire platform is modular. So you can pick and choose the small modules that are ideal for your particular use case. And secondly, you are restricting the propagation only to certain pre-approved nodes. So that increases the efficiency, that increases the speed and performance of these platforms as well, which is very essential for enterprises because today when we talk enterprise application, we are talking about uh, thousands and thousands of transactions per second. If you look at some of the leading card processing systems, they do transactions of 80,000 or 1 lakh transactions per second. So that's the kind of performance and efficiency which is required out of these platforms. And when a platform is open source and when all transactions have to propagate through each and every node in the network, that kind of efficiency and performance cannot be achieved. Make sense?
Yeah, yeah. Hello.
Okay. Any other question? Any other follow?
Yeah, yeah. There is one more.
Yeah.
Just give me 1 minute. So the next question to it is: are these nodes are standard servers put by the implementer, or these nodes are client machines?
So in a public blockchain, these nodes are individual people who are part of the network. So if you take a look at Bitcoin blockchain or Ethereum blockchain, there's no central authority, there's no government or no intermediary who's controlling the entire platform. The platform is used by the people and is run by the people. So anyone and everyone can be a part of that network. Even you can tomorrow go and join the Ethereum blockchain or the Bitcoin blockchain, and then you will also be a node of that particular blockchain. And when you join a particular blockchain, all the transactions in that blockchain, right from the Genesis block. Genesis block is the first block which is ever created for a particular blockchain, till the last block which has been added so far. All that data will be downloaded on your machine as well. And your machine can be anything. It can be a massive supercomputer or a simple laptop that you're using with decent enough memory to accommodate all the transactions that have taken place so far. So that makes you also a node of that platform. This is what happens in a public blockchain. When you talk about Hyperledger or other enterprise platforms. These nodes are basically nodes of, again, the concept is still the same because we're still in the blockchain phase. So the people who are part of that particular business network are the ones who are hosting these nodes. For instance, if I'm taking trade finance, for example, so in trade finance, the nodes would be the banks, that is the exporter and the importer banks. Then the port authorities could be the node, and the importers and exporters can be the node. So these 4 5 nodes can take place. But the advantage is that in Hyperledger, the nodes are restricted to only the parties which are involved, and the other parties who are not involved in that business or in that network or in that transaction do not need to be a part of this business network, thereby improving the performance and restricting the resource usage. Make sense?
Yeah, yeah, that's cool. So, so I think you can continue now.
Okay.
Hello. Yeah.
So next we'll talk about the working of Hyperledger. So let's see how Hyperledger actually pulls all these things off, the ones that we've discussed so far. So it all starts with one party. Let's say in our example, this party is Alice, looking up the other party, which let's assume is Bob, through a particular app, which in turn sends the query to a membership service and sends the transaction only to the peers directly affiliated. So this membership service basically keeps a tab of which parties should be a part of this particular business network, or to put it simply, which parties should be joining this specific network. So if I were to give you an example or draw an analogy, in this particular scenario in today's session, Amity is nothing but a membership service equivalent who's deciding which parties should be a part of today's webinar. So today's webinar is conducted by me, so I'm a party to it, and today's webinar is exclusively for students of Amity, so you guys are participants of this. But in this particular scenario, in this particular case, we don't have students from any other university, we don't have students from any other stream, because they are not party to this specific business transaction that we are currently engaged in. So that is what the role of membership services is. And both the parties that we are talking about here, Alice and Bob, both the parties now will generate a result in this two-party agreement, and both results generated need to be the same for it to get validated. But in other transactions where there are multiple different parties, other rules can also be applied as needed. So at the end of the day, any transaction that goes through, any transaction that is executed, needs to have a consensus, or simply put, a majority, that most of the parties should agree. Either if, let's say, 10 banks are working together, they might have a rule that at least 6 banks should agree, or 8 banks should agree to a transaction. Or they can also change that rule, saying that if the transaction is between bank A and bank B, then both bank A and bank B should agree, and out of the other 8, any 4 should agree. So those kind of rules can be created. And the validated transactions are then sent to a consensus cloud for ordering. And these ordered transactions are basically sent back to the affiliated peers and then committed to the ledgers. So this entire process we'll see as we move forward, this process of having an orderer and a committer peer and an endorser. And this same pattern of a transaction is needed by multiple industries where private and confidential applications are needed to be met by multiple parties without processing everything through a single centralized authority. So as opposed to having a single centralized authority to validate the transactions, they are basically relying on a consensus or a majority decision by all the parties involved in that transaction. And that is how Hyperledger basically pulls this off. More particularly, now we are talking about Hyperledger Fabric. So that is how it pulls all these things off. And in the next section, we will see how this entire thing basically works. That now that I've told you what Hyperledger is, how it pulls off permission blockchain network, we'll go through the architectural changes that actually make this possible and how the entire consensus runs and what are the different pieces like the peers, the endorser and committer peer that I was mentioning to y'all above. So let's understand this concept now. Let me again pull up my Word document over here. Now, the most notable changes can be seen in the peers which make up the whole network in case of Hyperledger. So the peers basically they are separated into two different runtimes and three distinct roles, which are the endorsers, committers, and the orders. And when an endorser and a committer peer are executed on the same runtime, the order peer is run on a completely separate, a completely different runtime. So this allows Hyperledger's modular architecture that I was referring to earlier to allow properties like consensus and a few others to be plug and play features. So different business networks can have their own consensus algorithms, their own systems to utilize on the particular network, which in turn allows a high degree of personalization to the network according to the needs of the business. So that is how it basically functions. Now let's talk about these orders and peers that I've been referencing to since the last couple of slides. Now, again, I'll first show you this example. So in Ethereum blockchain, we have these different nodes and each node is an equal. Each node is called a peer. Each node has the exact same privilege. That is how Ethereum blockchain works. But in case of Hyperledger, they have this concept of order, and besides the orders you have these other nodes. So now the way this entire process works is that uh, each node will issue a new transaction. So let's say we write a simple chain code. Let's say now, this chain code basically is a smart contract. So, any program which is written on top of Ethereum blockchain is usually referred to as a smart contract. But if you write this program on top of Hyperledger Fabric, then it's usually referred to as chain code. So, it's just a change in terminology, but nothing beyond that. So, let's say there's a simple chain code which reads that A's initial value is 0 and later A's value becomes A plus 1. So this is what my chain code is. Now I deployed this chain code on each and every node. So this specific thing that we're talking about is a business network. So this business network has four parties who are together, who are working together, who are doing business together. So that's why they are part of this specific business network. Now, when this new chain code is deployed, again, let's call it smart contract one. This smart contract one also gets deployed on each and every node in this particular business network. So the difference between this and Ethereum is that here the smart contract is being deployed only on the parties who are part of this business network, not the entire network. So the entire Hyperledger might have thousands and thousands of uh, business networks, and here we are looking at only one business network. So the smart contract is deployed on each and every node. Now what happens is that initially when a new transaction is initiated, each node will generate a read write pair. So in this case they will basically when they execute this code, the read write pair will say that the read value is 0 and the write value is 1 because they're reading 0, which is the initial value, and after execution the value has become 1 because it's A is equal to A plus 1 and A's initial value is 0. So that read write pair is what they generate over here, and each node in the network will generate this read write pair. Once they have generated the read write pair, they will send the read write pair to the orderer, and the order will then see what the majority is saying. Now over here, for some reason, if node 3 has read 1 and written 0, unlike the others, it will send that corresponding read write pair to the order, and the order will see that out of four nodes, what does the majority say? The majority is saying that the read value should be 0 and write value should be 1. So it'll the order will finalize on that value and send it back to each and every node in the network. And once the nodes receive the final decision from the order, then they will write that particular thing to the actual ledger, to the blockchain ledger. So till then, this initial read write value that was generated was never written on the ledger. It was localized to that specific node and sent to the order. Only after the order gave a confirmation was that value written on the ledger. So that's how this concept of order and pair basically works. Do note over here, these nodes are the ones which have a copy of the smart contract, but the order never has a copy of the smart contract. So the decision that the order makes is contingent on the majority of the data that it has received and not on anything else. So it doesn't make its own decision, or it doesn't think what is right, what is wrong. It will just receive data from all the other peers and make the decision based on what the majority is saying. So that is what the order is all about. And when we talk about these nodes are also called pairs. And over here, there were two functionalities that the node did. One is that it generated the read write pair, and second, once it received a message from the order, it wrote that read write pair on the ledger. So the first functionality is called as an endorsement, and the second functionality is called as a commit. And because of this, a node can actually be separated into two parts. So you can have a separate endorser and a separate committer as well. In some cases, both the endorser and committer role is executed by the same node. And in some cases, that role is separated, and one node plays the endorser, the other node plays the committer. So both options are available, and that's the reason, broadly speaking, we have three kinds of pairs. We have the order, we have the committer, and we have the endorser. So these are the three nodes that I was talking about. And over here, the endorser is basically the nodes that simulate the transactions pertaining to the network and also prevent the occurrences of non-deterministic or any kind of unstable transactions. And it is important to note that while the committers may or may not be endorsers depending on the network restrictions, all endorsers, they act as committers on a Hyperledger network. So as I said, you can have the nodes as one entity as well. The second node, which is the committer, uh, this is the most simplistic role, and their only role is to append the validated and ordered transactions. So the transaction with the order sends them to the specific ledger, which is the Hyperledger, once returned by the by the order. So normally a committer only does this functionality of receiving the transaction from the order and adding it to the ledger. And lastly, we have the order, which works on different runtime. So these nodes are basically responsible for running the consensus algorithm on a network and can be very well thought of as a bodyguard of the network who validates every transaction, deciding whether or not it should be added to a ledger. So that is what an order basically is. Some important aspects about the order. So orders are basically the heart of your Hyperledger Fabric network. They are the connecting pieces for all the members of the network. Their main responsibility is to order all the incoming transactions into a block and then message it through something called as the Kafka. So Kafka is the messaging protocol that Fabric uses, and they message it to the concerned nodes. And once the message is sent, the committer can then add that particular transaction to the blockchain. So that is what your order, committer, and endorser basically are. Got this concept, guys? Any questions here? Any questions, guys? Okay, so let's move forward. Now, Shubham, I believe earlier you had asked me what's the difference between these platforms. This is where we'll talk about that difference. This is where we'll understand what's the difference between Hyperledger and some of the platforms which were created prior to it, like Ethereum and Bitcoin blockchain. And we'll discuss those differences and those disparities based on certain parameters. So let's get started with that. Unless there's a question.
Yeah, so one question was there. So Hyperledger Fabric is used to develop application which can be deployed in private blockchain, right?
Hyperledger Fabric is used for both purposes to create this private business network and then deploy an application on it. So for both reasons, you use Hyperledger Fabric.
Yeah. Okay, okay. You can continue now.
Okay. So now we compare the three most popular blockchain networks. And the first parameter that we compare this based on is cryptocurrency. So both Bitcoin and Ethereum blockchain, they have their own innate cryptocurrency. In Bitcoin blockchain, it's Bitcoin, and in Ethereum blockchain, it's Ether. These cryptocurrencies, they serve as fuel for their respective blockchain platforms. So if you want to do anything with the Ethereum blockchain, or if you want to interact with the Ethereum blockchain, you have to spend the transaction fee in Ether. Similarly, in Bitcoin blockchain, you have to do it in Bitcoins. But Hyperledger does not require any kind of cryptocurrency. Hyperledger platform is independent of cryptocurrencies. If you are building a certain platform where you want an innate cryptocurrency, then you have the option of generating tokens on that platform, but it doesn't rely on it. It is not contingent on it. One of the reasons why Bitcoin and Ethers were created is because the platforms were public, and on a public platform, it's important to incentivize people in order to keep the platform alive or to uh, confirm transactions or participate in consensus. And Bitcoins and Ethers basically serve as that incentive for this group of nodes which are called miners who actually keep those networks alive. But on Hyperledger, because the entire goal was to use it for enterprise applications, that incentive wasn't required. Because let's say it's a banking network which is using Hyperledger, they don't need an incentive in the form of cryptocurrencies to keep the network alive. The fact that they are a bank and that they are in operation and multiple people are utilizing their services is more than enough for them to keep a network which actually executes those services alive. So that's the first difference. It's in terms of the cryptocurrency. Bitcoin and Ethereum rely on their innate cryptocurrencies. Hyperledger does not have it. The second is network. So both Bitcoin and Ethereum blockchain, they are public networks. So public network basically means that anyone and everyone can join the network, anyone can utilize it, anyone can interact with it, and there's absolutely no restriction. But Hyperledger is a permission network, so only certain restricted entities can be a part of a specific business network and utilize that business network for running certain kinds of transactions. So that's the second difference in regards to the network. The third difference is pertaining to the consensus algorithm. So in Bitcoin blockchain, we use something called as the SHA-256 consensus algorithm. There's a typo over here. It's not SHA-26, it's SHA-256. And Ethereum blockchain uses something called as the ETH hash as a consensus algorithm. And Hyperledger Fabric uses something called as the practical Byzantine fault tolerance algorithm. So the consensus algorithm is different in different platforms. Then you have the concept of smart contract. So as mentioned earlier, Bitcoin blockchain doesn't support smart contracts, but Ethereum and Hyperledger do support them. In Ethereum, the smart contract is usually written using a programming language called Solidity, and in Hyperledger Fabric, it uses languages like Node.js, Java, and Golang. In the coming years, they might build support for some other programming languages as well, but at present, these are the three supported programming languages. And the smart contracts written on Hyperledger are called chain codes. And talking about the language of the platform. So earlier, the language that I was talking about is the language used to write smart contracts on top of the platform. That is what Solidity and Java, Node.js, and Golang was. Now we are talking about the programming language used to build the entire platform. So in Bitcoin blockchain, that has been built using C++. Ethereum blockchain has multiple clients available, right from Golang to Java, C++, and a few other programming languages as well. And Hyperledger has been primarily built on Golang. Uh, Now they are building a client version on Python as well, but Golang is the prime language which was used to build Hyperledger Fabric. All right. The next thing that we'll see is the projects under Hyperledger. So there are few noteworthy ones like Hyperledger Fabric and Sawtooth Lake. Hyperledger Fabric has been extensively used in supply chains and market networks, and Sawtooth has seen success in the fishing industry. There are also certain other Hyperledger projects like Iroha, which is used for developing blockchain-based mobile applications. Another project called Hyperledger Indie, which is used for decentralized identity and databases for business networks. So there are a lot of different projects that come under Hyperledger. In fact, we can also take a look at it on their website. So if I go to hyperledger.org, you can see all the projects that are supported. So these are different projects that Hyperledger has supported over the years, and new projects keep getting added. And they have a huge community as well, a community of members you can see over here. Some of the leading organizations in the world are part of Hyperledger as a project. So you have all these different members who are part of the Hyperledger umbrella project and the Hyperledger platform. So a lot is being done in this space. A lot is being developed, and the development is ongoing. They are trying to find new applications, new use cases, new ways of using this underlying platform. So that's a continuous and ongoing process for organizations when they are trying to build new applications and come up with new ways to interact with each other. So moving forward, we've seen these projects. Now, the next thing that we'll talk about is the reason why organizations are interested in Hyperledger, or the advantages that they are trying to, extract out of blockchain as a technology in general and Hyperledger as a platform. So, if you look at the current business network, everything is centralized. Everything has intermediaries in between, whether you take stock markets or cross-border remittance. There are n number of intermediaries. If you take stock market, for instance, you have your settlement agents, you have your depositories, you have your banks, you have your brokers, traders, so many intermediaries, and each intermediary basically serves as a bottleneck, because if that intermediary is non-operational, you cannot move forward with your transaction. And secondly, the intermediary serves as a reason for increase in cost. So because each intermediary charges its own fee, at the end of the day, the brunt of now this excess fee falls on the clients itself. So what these institutions are trying to do, they're trying to eliminate these intermediaries and work in a more decentralized manner by use of blockchain as a technology. So that's the reason why industries are saying that blockchain will change the way we do business. Traditionally, all businesses have relied on centralized systems. Whether you talk about a bank, you talk about an insurance, their data is in a central repository, their data servers, or their data stores, and that is where everything is held. that also causes security issues because for any hacker, for any attacker, the attack vector is known, the location is known. So all he has to do is go and try to attack that centralized location. And if he's successful, he can go and manipulate the data. But with blockchain, they're trying to create a more distributed system wherein even if one particular node fails or one particular node is down, firstly, the process still continues, so there are no bottlenecks. And secondly, the data still stays secure, the process still stays secure, and the entire transaction can be executed in a proper manner. So basically, with blockchain, businesses are trying to eliminate intermediaries and create a more robust system, a more robust process for executing different kinds of transactions. And there are certain unique advantages of Hyperledger which actually help in achieving these goals. So the first one is your permission membership. So the idea of having a permission membership basically allows organizations to use the advantages of blockchain, but still keep data secure, keep data private and confidential. And based on this membership services, based on the permission membership, only certain restricted parties can interact with each other. Only they can deploy smart contracts, and only they can share that smart contract with each other. So that's the first advantage, your permission membership. Secondly, it has rich queries over immutable distributed ledger. So if you look at any banking service or any enterprise service, queries are a very important aspect. So queries in traditional terms or in database terms, it means that you can, once data has been stored in the database, you can remove certain data based on certain criteria. So if let's say I'm an e-commerce platform who has collected data of different users from different locations, ordering different products, paying by different mechanisms. Then tomorrow, if I want to know that in which locality do people buy shoes using credit card the most, so based on these criteria, I should be able to pull data. So for that, I need to write these queries basically. And with Hyperledger, the support for queries or the support for pulling data based on different criteria is significantly better than the other platforms that exist. So that's the other advantage of Hyperledger. The third one is its modular architecture. As we were discussing earlier, by running these different peers on different runtimes, they allow for a modular architecture. So if one business network is using a certain consensus algorithm, and if the other business network wants to work on a very different consensus algorithm, they can still do it. There's no restriction, and it can be seamlessly implemented. The next thing is protection of digital keys and sensitive data. So again, the traditional ability of any blockchain, whether it's Ethereum or Bitcoin blockchain, to actually store these keys in a secure manner and keep the identity hidden is translated on the Hyperledger platform as well. So the keys and data, it still stays secure, it still stays protected. The next is data on a need to know basis. So this again relates to the aspect of rich queries and permission membership. Owing to those two advantages and the infrastructure implemented for those two advantages, you can restrict data to certain restricted parties who have permission or who are authorized to view that data. And at the same time, you can pull data based on certain specific conditions as well. And finally, we come to performance and scalability. So compared to the public blockchain networks, which require a huge amount of resources to cater to the fact that all data needs to be propagated throughout the network, uh, uh, Hyperledger has a significantly better performance aspect because Hyperledger Fabric works on certain limited business networks, certain limited organizations, and through that it can actually provide a much better performance metric as compared to the other platforms. And some of the problems of the existing blockchains that Hyperledger has overcome, firstly, the limited throughput. So the performance is restricted, especially in case of Ethereum and some of the other platforms. And as compared to them, Hyperledger's performance is significantly better. Second is the transaction confirmation. So in Ethereum and in Bitcoin blockchain, those transaction confirmation takes more time as compared to Hyperledger because the transaction needs to go to every node and receive a confirmation from them. The next is anonymous processors. So in Ethereum and Bitcoin blockchain, you have no idea who the nodes are and who's sending money to whom. Whereas in Hyperledger Fabric, because of the membership services, at least a particular business network knows who the other members are. So they do have anonymity when compared to the outside world, but within the particular business network, there's still some level of knowledge and not complete anonymity, as in case of Ethereum or Bitcoin blockchain. Next is settlement finality. So the settlement of transactions, because the consensus is transaction level, the settlement can take place at every transaction as opposed to Ethereum and Bitcoin blockchain where it's block level confirmation. The next is cryptocurrency. So Ethereum and Bitcoin blockchain have been designed with cryptocurrency at the center, but Hyperledger doesn't work that way. So there's no reliance on cryptocurrency at all. Next is poor governance. So if you compare to Ethereum and Bitcoin blockchain, Hyperledger certainly has a better governance, being a part of the Linux Foundation, which is known for creating open source projects like these. And finally, you have the privacy aspect. So when we talk about privacy, again, due to the idea of membership services, Hyperledger has a better privacy concept as opposed to Ethereum or Bitcoin blockchain, where all transactions can be viewed by each and every party, each and every node in the network. All right. Any questions here, guys? Any doubts, any queries so far?
Yeah, Mr. Nakul, hello.
Yeah, sure.
Yeah, there are three basic questions. Your previous explanation. So Fabric doesn't work in Windows.
It does. Fabric can work on all the operating systems that we have. It works on. It has Windows equivalency. It has Mac equivalency and Linux as well.
Okay.
Ubuntu. Yeah.
Okay. Next question. Hyperledger seems less secure than Ethereum blockchain. Is that true?
No, from a security aspect, it has equivalent or better security than Ethereum. And in addition to that security, it gives you an added layer of privacy as well, which Ethereum lacks.
Okay. So chain code is written in which language?
Golang, Java, and Node.js. So currently, these three languages are supported to write chain code, and with time, they are planning on adding support for other languages as well. But at present, it's these three which are supported.
Okay, got it. Yeah, Mr. Vipin. Hello.
Yes, hello, Nakul.
Yeah, you can talk. So, Mr. Nakul, Vipin has some questions. So, Vipin, continue, please.
Yeah, Nakul.
Sure.
So, Hyperledger has different fabrics, and say if we have been given, say, from architecture point of view, so which fabric should we use? How do we select that? And what are the basic difference? Like how do you choose, say, one fabric over the other?
Sure. A very valid question, and unfortunately, there is no specific answer to this question. So I get this question, in every batch that I take. That how do I decide which platform to use, or which is that one platform that will be the go-to platform? it's not just that I don't have an answer for it today, but it's quite possible that even in the next 10 or 20 years, we might not have a specific answer to this question. And here is why that's the situation. Now, to draw an analogy, consider it like developing a website or like developing a mobile application. Which language to use, whether to go with PHP, within PHP, whether to go with CodeIgniter or Laravel, or whether to move ahead with Node.js to do MERN and mean stack development. How do we decide any of these things? So every application or every development, it varies when it comes to these technologies. Same is the case with Hyperledger as well. Within Hyperledger, there are these different platforms, and currently the industry is still in a situation where they're trying to figure out which is uh, the one ideal platform, which could be the one go-to platform, and because of that, it's in a very nascent stage and it's in a very transient stage. I call it nascent because the history of blockchain itself is very limited. We hardly have 4 to 7 years of history in this entire space, and the real applications, the real use cases, the real deployments have only started about 2 3 years back. So that's the history, and I call it transient because in this limited history that, for instance, Hyperledger has, for instance, Fabric has. We started at version 0.6 and today it's on version 1.4, and there is a stark difference between these two versions. So it, to be completely honest, I if uh, Fabric point 6 and 1.4 are both put in front of me, I would say that these are two separate platforms altogether. So, even within a platform, those are the kind of advances that are being made because the industry is trying to figure out which is the ideal platform that we can go to for all applications, or how to distinguish between different platforms for different applications. So, to be honest, there's no specific answer, but one way to look at things is that the entire purpose of POC is to test out these different applications. So we as a company, when we are working with our clients, the first phase itself is to understand their requirements and figure out what are the ideal platforms for that. Once that part is done, once that has been achieved, then we start building POCs. And the second important thing over here is not just what your choice of platform is, but what your counterparts or what your industry peers are using. Because again, this takes me to the first point that I had made. Hyperledger, or sorry, blockchain as a technology has advantage only when multiple organizations are utilizing it together. But if you use it alone in your organization, it's not going to give you any advantage. So how can you have multiple organizations using it together? Only if you're using a common platform to work together. So that is how you look at platforms. Currently, there's no one go-to platform. For in fact, each application, at least each of the prominent applications have been tried and built on different platforms. So it's not just that finance applications have all been built on Fabric, and IoT applications have all been built on Sorted Lake. There are so many IoT applications that have been tested on Fabric, so many banking applications that have been tested on Sorted Lake, and so on and so forth. So that is where the entire industry is today. Make sense?
Yes, one more question. Say,
Yeah.
so I have a consortium, and maybe I'm working for Idea, and someone is working for Airtel, and we are, let's say, using any of the fabrics. So, do we also need to have same cloud service like AWS or IBM Bluemix or Google Cloud, or that can differ?
Not necessarily the same cloud service, but yes, you need to have the same business network. So the business network has to be common between all these parties to be able to interact with each other, but each can host their node which connects them to this business network in their choice of network. So one can have AWS, the other can have Bluemix, the third can decide to host it themselves using Raspberry Pi servers. So that is fine. The infrastructure is not uh, too much of a hindrance, but the network has to be common.
So the integration between, say, one system and other system is mainly on REST services, or for that also Hyperledger provides any fabric.
No, so the integration is like from your front end to the Fabric network is of RESTful API services, but the Fabric network is basically the connecting piece. So the core engine of a Fabric network is the consensus. That is the one which is connecting all the different nodes together to create a business network.
Uh,
Make
Thanks.
sense?
Yeah,
Sure,
thanks, Akur.
sure.
Yeah, so
All right.
next question is there any difference between Solidity and chain code?
Technically, yes, they are written in two separate languages. Solidity, firstly, is a programming language to write smart contracts on Ethereum blockchain, and the smart contracts written on Hyperledger are termed as chain codes. And they are written on Golang, Java, and Node.js, as I had mentioned earlier. So, terminology wise, chain code is usually associated with Hyperledger Fabric, smart contracts is usually associated with Ethereum blockchain. And technically, they both have different programming language, different architecture, etc. But conceptually, they are both programs which are written to run a specific application or a specific use case.
Okay. Next question is there any government organization that has implemented Hyperledger blockchain or any government body has recognized Hyperledger blockchain?
A lot of government sectors are using they are running tests on these blockchain platforms. It's not just Fabric. They have also been using multi-chain and a few other platforms. They are basically in the POC stage. They're trying out different applications like running voting systems. So there's a company called Follow My Vote in Virginia, US, and they are doing these POCs with some of their American clients. Then even in India, there are a few state governments who are trying to use blockchain for securing land titles and for securing academic documents, etc. So a lot of work is going on. The Honduran government had done a POC. For land titles, to secure land titles. I don't remember which specific platform, but I don't think it was Hyperledger. They had used some other platform for that. But even Hyperledger is being used by a number of these organizations for running their POCs. I think the Spanish government had done one POC on Fabric, if I'm not wrong.
Okay, okay. If anyone
Yeah.
has any questions, can just raise your hand. We have last 5 to 10 minutes. Hello.
Yeah. Should I continue?
Yeah, yeah, you can continue now.
Okay. So the next thing we are taking a look at is the entire Hyperledger umbrella. So you have three different segments there. You have the infrastructure, which is basically your cloud-based servers or your hosted servers. Then you have the different frameworks as we had seen. So Hyperledger Fabric, Iroha, Indy, Sort of Lake, Burrow, they all come under frameworks. And then in order to better utilize these platforms, a number of tools have been built of to facilitate deployment of applications. So you have Composer, which is a tool that we'll see later today. Then you have Explorer, which allows you to track all the transactions, and you have Cello, which is used to offer the applications built on Hyperledger through a software as a service model. So based on that, there are different tools and different frameworks, different kinds of infrastructure which is supported on the entire Hyperledger framework. The next thing that we'll take a look at is the entire architecture of Fabric. So on the top, you have your APIs and SDKs. This is the layer basically which helps you connect your Hyperledger Fabric to the front end application. So earlier, when one of you all asked me that question, that how is the interaction? It's basically through these API layers which Fabric gives itself, which are used to connect your business network to any front end application, whether you build a mobile application, web based application, Windows application, whatever it is, you can interact through these APIs. The next layer is your membership services, which is basically what allows you to create a business network with certain restricted organizations, certain restricted parties associated with that particular business network. The next thing, you have your entire blockchain service. So that includes your consensus algorithms, your P2P protocol, the entire distributed ledger and storage. And finally, you have the concept of chain code. So chain code is basically the smart contract equivalent, and usually chain code makes use of Dockerized systems. So let me just spend a couple of minutes explaining how these Dockerized systems work. Now, Docker itself is, a lengthy topic, so you can always read more about it. But here I'm just explaining the concept of Docker as relevant to, chain code, or the main part of Docker, which is leveraged in this kind of programming. So now let's say you write a certain smart contract, and let's say the smart contract needs to give you an output which reads hello world. So this is the output that your smart contract needs to give. Now, for some iteration, if you want to change this output from hello world to hello India, what will happen is that you need to go and first edit the code, then again compile the code, and then execute it reading hello India. And after that, if you want to again go back to hello world, you again have to go and edit the code, compile it again, and execute it. So this is quite a painful process. Instead of using this, what they make use of is Docker containers. Now, what this Docker basically does is that you can have two separate instances of this code with the output change. So one Docker container will have an output hello world, and the other will have an output hello India. So at every execution, you can determine what Docker you want to execute it through, and accordingly you can keep switching and keep getting the outputs that you require. So that is how they make use of this concept of Docker containers. And the entire purpose of these Docker containers is to facilitate those minor changes, and in order to ensure that every iteration doesn't require you to go and edit the code and recompile it, etc. So that is what this Docker containers are, and that is what they make use of uh, in the chain code service. So they have a container system and secured registries which they leverage in order to utilize within this specific architecture. All right. So this was about the architecture. Now we'll talk about Fabric. So Fabric is, as I said, one of the most common and most widely used platforms under the Hyperledger umbrella. And the reason Fabric has been used so extensively is because over the years it has gone through a number of upgrades. And if you want to ever judge which platform is famous, or which platform is being used widely, simply open the GitHub repository of that particular platform and see how often does it receive commits and comments and updates. And if you look at Fabric as compared to the other platforms, this has the most number of commits and the most number of code updates, which means a lot of developers are working on this, a lot of developers are contributing to this, which makes it one of the most famous platforms within the Hyperledger umbrella. And this platform has certain components associated with it. So first you have the Golang, which is the programming language. The first modules of Fabric were written in Golang, and Golang is a highly performant programming language developed by Google developers. And a basic understanding of Golang will also help you debug the components profoundly when required. So not only can you write smart contracts or chain code on Fabric using Golang, but you can also debug the entire underlying platform because it's written in that same language. From that perspective, it is very useful. And chain code is usually written in Node.js because of the support it has for Fabric, but even Golang can be used for writing the chain code. The next component is your Node.js. So the ability to write JavaScript on the backend has changed the way we see JavaScript now, and it's asynchronous and event-driven behavior, which is owed to the V8 engine. So that is where Node.js actually came into being. The idea was to be able to write uh, the JavaScript on the backend as well, and Node.js actually gave that ability, and it is extensively used in Fabric as well. The next concept is Docker. So Docker is exactly what we saw right now, and Fabric heavily uses Docker for all its microservices. Therefore, it is very important to understand the basics of Docker to work with Fabric Network, and it also uses Docker Compose for orchestration, and you can use something called as the Docker Swarm or Kubernetes to deploy this into multi-VM production environment. So uh, basically, when you develop and deploy enterprise solutions, it usually uses Docker Swarm or Kubernetes for those kind of deployments. And the next is your gRPC and protobufs. So generally, the services they communicate with each other using REST APIs, and even in traditional client service models. For example, front end talks to the back end using REST APIs, and the data is sent across in JSON format, which is just a key value pair. But this has downsides, and Google's gRPC has given a better way to communicate among different services where the data is transferred in a binary format or in the form of protobufs. So basically, the purpose of using protobufs and gRPC as opposed to your traditional APIs for internal communication is better performance and latency. And Hyperledger Fabric uses this extensively. So this is another important component. And finally, you have your Kafka and Zookeeper. So Kafka is basically a messaging system which is used for sending and receiving messages between your orders and your peers and the entire network. And lastly, Zookeeper is basically it creates messaging channels which can be used for sending and receiving those messages easily. So your Kafka and Zookeeper basically combine to create that kind of a messaging service within your Hyperledger Fabric. The next thing that we have is your business model. So when you create a business network and when you deploy a certain application on top of it, there are three important files that you need to interact with. One is your model file, which talks about the assets, the different participants, and what kind of transactions are going to exist. The second is your script file, which actually gives you the detail of every transaction that takes place. Then you have your access control file, which gives the permissions, etc., that which node can view what transaction and how they can interact with each other, etc. And lastly, you have your query file. This file is an optional file. You do not necessarily need it, but you can use it if needed. So query file is where you can write some predefined queries that you can utilize later on to fetch certain important data or certain specific data. So together these files come and they make your business network archive, which is nothing but your smart contract equivalent that can be deployed either on a cloud-based system or a web-based system, whatever it may be. So that is what your Fabric business model basically comprises of. And now we'll take a look at these same files using a tool called the Hyperledger Composer. So as I told you, we will be making use of one of these tools that we had seen earlier, the Composer Playground. And this tool, the way it works is basically it's a web-based tool, so you can easily interact with it, you can easily connect with it. And now we'll understand how this tool basically works. So one second. So when I go in, I would first want to deploy a new business network. Once here, I can give it a specific name. I'm retaining this test name that they have, basic sample network. I can even give a specific description if I want to, and an email ID. Then I'll go here and I'll select an empty business network. So I select this empty business network and I say I want to deploy this business network. So this business network is now ready for my customization. I go and I connect to that business network. The first file that I can define is a README file. It's not necessary to define this file. This file just contains some instructions or some message that you want to give, like what kind of smart contract this is, what you're doing with this, etc. The next file is your model file. So to create your model file, basically, one second, I'll use a test file that I have. So your model file, as I had told you earlier, is a file which contains the basic information about the parties which are involved over here, the asset that you're trading, and the kind of transactions that can take place. So here I've created an asset called commodity. And this commodity has different identifiers like the trading symbol, description, quantity, owner, etc. Then I have a participant called a trader who has his trader ID and first and last name, and then it's the eventual trade of the particular asset. So that's basically my model file. Then I have my access control file. So again, let me just take the content for the access control file. So this is my access control file over here. This tells me what particular entity has what privileges. So here, for convenience, I've just said that all participants have all kinds of access required, but you can have specific access as well, that one party can only view the transactions and one party can only edit the transactions. The next thing is your transaction file. So I'll add that file, which is nothing but a script file. So here I have added my transaction file, and this is the transaction file over here. I copy it and I save it over here. So this becomes my transaction file, which tells me what things will change when the transaction is made. And finally, once all of this is done, I'll say I want to deploy this network. So here, this network has been deployed. Now I can go and test this business network. So when I go to test it, first I need to add my participants. The first participant that I'll add is over here. So this is my first trader who I'm adding over here. Then I'll add one more participant so we can actually do the transactions between them. So this is my second participant that I've added, trader ID 2. And lastly, I'll add an asset over here, so a commodity. So I'll hit this create new, and I'll add this specific asset. So here you can note, initially I'm saying that trader 1 is the owner of this specific asset. So here I've used trader 1 as the owner ID, and I say create new. So you can see that trader 1 is now the owner of this ID. Then I'll go and submit a transaction. So this transaction basically will change the ownership of that particular asset. So I've put in this transaction, I say submit. And now if I go back to my commodity, here you can see now the owner of that transaction is my trader 2. If I want, I can also check all the transactions. So this will keep a tab, a history of all transactions which have been executed so far. So this is one way in which you can run a simple business network. If you go back here, I had selected an empty business network. You also have the option of creating your own sample network and deploying it over here, or creating a network based on certain predefined roles. So those options also exist over here. The second important thing to understand here is that why did I use a composer? So composer is basically a shorthand tool, and it eliminates the need for me to run the heavy lifting of deploying a business network and creating an order, a committer, a peer, etc. So if I don't want to use composer, then I can actually generate my own orders and pairs as well. So for that, either you can deploy your own Docker system, or for demo purpose today, I'll show you all the same thing using a web-based Docker lab. So here, if I go, I'll first create a new instance, and initially I'll take the admin privileges by giving the sudo su command. Now I'll create a new directory. So I'll say make directory fabric dev servers. So this is a new directory that I've created, and then I will go inside that directory. So this is nothing but your command prompt equivalent that I'm showing over here. So y'all can, because I'm using Docker Labs, which is web-based system, that's why I'm using their command prompt. Otherwise, you can deploy Docker on your machine, and you can use your own command prompt as well for the specific activity. So now I've created a new directory, and now I'm entering into that directory. So I say fabric dev servers. So I've entered into that directory. Now what I'll do is I'll run a curl command. So that will basically download a sample network for me and store it in this fabric dev server. So let me just download that particular command. Just one second. Just give me a second. I'll pull up the link for that. All right, so here is the link. Basically, what I'm doing is I'm downloading a sample business network whose code is already available on the internet. So I'm trying to pull that specific code over here. One second, guys. I just made a typo, so I'm clearing that out. So this curl command will go and download that specific code for me. And once that has been downloaded, the next thing that I'm going to do here is give the tar command. So the tar command, basically what it does is it unzips the file. So initially the download that has taken place is in the form of a zipped file. So now I'm unzipping that file. One second. Just one second, guys. Okay. All right. So that's done. Yeah. So now it has downloaded. It has unzipped that file for me. Now I will go into that new folder that I had created. Fabric dev servers. Now I will download a sample network. So the sample network is in the form of a shell file. So I'll say download fabric.shell. Now you can see over here the amount of download that is taking place. It's in hundreds and hundreds of MBs, and for this reason, I was using a web-based Docker system as opposed to my own Docker system. Otherwise, for every iteration, I'll end up spending 1 or 2 GBs of Docker storage. So that's why I'm using this. But here, it's basically downloading all the images and the entire sample fabric network. So just give it a couple of seconds. It's huge data to be downloaded. In the meantime, if you'll have any questions, you all can ask me. So once this download has completed, the next thing I'll do is start this fabric network. So this fabric.shell that I just downloaded, I'll start that fabric network. And once it downloads, so just give it 15 to 20 seconds. All right. And once this has been done, I can then actually check those images. So I can check my fabric network. If I give the docker ps command, it'll show me that it has created one peer, one certification authority, one order, etc. So basically, what I have done over here is manually I've gone in and I've created one peer, one order, one committer, etc. Which in case of Composer, I didn't have to worry about. The backend itself took care of those things. So I just wanted you all to get a flavor of how these things work. Of course, this is not the entire Hyperledger Fabric operation. This is just a start of it. I just wanted you all to have a basic overview, a basic understanding of how these things work. This topic is much more detailed, and I have written on this in my book. So the book titled Hyperledger for Business, sorry, Blockchain for Business with Hyperledger Fabric, where I've used these different ways of creating examples and different use cases like land title, etc. So that's basically a brief overview about Hyperledger Fabric. And with that, we come to an end of today's session. So let's just summarize the topics we've covered in today's session. We started off by saying what Hyperledger is. Then we saw the need of Hyperledger in today's IT industry. We saw how Hyperledger pulls off a permission blockchain network and the architecture changes that make them all possible. Lastly, we compared Hyperledger to the two most famous blockchain networks, that is Bitcoin and Ethereum. And we also took a look at the demo using Composer and Docker Labs. So with that, we come to an end of today's session, guys. Now we have the last 5 to 10 minutes left, which I want to open up for any questions, any queries, any doubts that you guys have. You can go ahead and ask me any questions.
Hello, am I audible?
Yeah, I can hear you.
Yeah, so you have given us comparison with Ethereum and Bitcoin, but what about Corda? So how much is it different with Corda?
So Corda again uses its own architecture. In fact, the consensus that Corda uses, they have developed their own, node-based system for that, and the End goal is same for both Fabric and Corda to be a supporting framework for enterprise solutions, but the architecture is different in both platforms. So Corda makes use of a concept called notary nodes in order to bring about consensus, as opposed to the practical Byzantine fault tolerance algorithm of Hyperledger. Uh, Plus, the use cases initially that Corda supported were primarily from the banking sector, but now they have evolved into various other sectors as well. Also, from a performance standpoint, they have different metrics. So, Corda it processes significantly more transactions for certain kind of use cases. So there is a lot of disparity in architecture and performance of both, but end goal is still the same to use it for enterprise applications. Uh,
One more question. So in Hyperledger Fabric, say, which fabric should I use if I have more number of users? Is each fabric also limited to, say, if you have 100 users or 1,000 users or 1 lakh users?
No, the users are not restricted. Yes, your performance will get impacted based on the increment in the number of users, but there's no rule of thumb that you have to use Fabric for 100 users and Sorted for 1,000 users. There's nothing like that. So every platform has support for any number of users. You just have to give it the right infrastructure and at the same time be prepared for some degradation in performance. Make sense?
Yeah, thanks, Ram.
Sure. Any other questions, guys? Any other doubts? Any other queries?
Yeah, there is one more question.
Sure.
What are the roles one can look up in the Hyperledger projects, specifically in Hyperledger Fabric? Are all the roles code base?
See, most of the codes initially they are code based. So you would most probably for Hyperledger itself, you'll be an application developer building new applications, use cases on top of Hyperledger. Some roles are also on the operations side, operations and infrastructure, where you will be setting up the entire environment, the entire ecosystem. So that could be the second role. And third role is more of a product manager, where you are assisting in utilizing these advantages of blockchain and Hyperledger into certain traditional systems. So if you come from, let's say, trade finance background, you already know how trade finance takes place in the traditional ways. You learn what a blockchain can bring from the perspective of benefits, and then start developing custom applications using Hyperledger as the infrastructure and for your specific industry. So those are the broadly speaking three categories of roles that you can pursue.
Okay. Next question is, what are notaries? How does it differ from endorser and committers?
So notaries is, an entirely different concept. It comes under the Corda section. So prior to explaining notaries, there would be, other aspects of Corda that need to be understood, right from some basics of Kotlin, which is the programming language that they utilize. Uh, but uh, just to give you an overview, the entire concept of notaries is based on custom consensus, I would say. So it's primarily that if there are 100 organizations, then based on the transaction, that if this is the transaction, then these are the consenting parties. If that is the transaction, those are the consenting parties. That is the broader idea. Of course, we cannot get into the details of notary nodes and how it is deployed, how it is utilized in just a couple of minutes. That would be an entirely different topic altogether. But the main fundamental is because they have built a Corda for enterprise applications where they have tried to accommodate hundreds and hundreds of different institutions on the same platform. So to ensure that contingent on every transaction which institute should be a participating consenter, they have built this concept of notary notes.
Okay. Guys, we have last 2 minutes. Any more questions? Yeah. So I think we have discussed a lot of questions. So now it's time to close the session. So thanks all students for joining this webinar. Hyperledger Fabric Blockchain in Business. So thanks, Mr. Nakusha, to conducting this webinar and addressing it in a brief manner. Okay, and definitely we will have more webinars from Mr. Nakul in future. So thank you, Mr. Nakul, and thanks all students.